Hi guys, today you're going to learn about isotopes. And isotopes are still atoms, but there's something special about them. An isotope is when you have the same element, but it has a different number of neutrons, which means it has a different atomic mass. So think about it, if I came to class on Monday and I weighed a certain amount, and then I went home and I ate nothing but cake for a whole week, because cake is delicious. And then I came to class the next week, I would still be me, but I would weigh a lot more because of all the cake that I've eaten. That's an isotope. It's still the same person, it's still the same atom, but the weight is different because it ate a whole bunch of cake, or for an atom, it added a whole bunch of neutrons. So that's going to be represented in some different ways. These are all the different possible symbols you could see. So notice what's in common. In this example, they all say lithium, or Li, right? That's the same thing. So I know that it's the same atom. But they're representing the mass with this 8. So see how they all have the 8? That's just a different way, whether it's written after the word or after the symbol, or notice it's in the top left here. That number represents the mass number. So in this example, lithium has a mass of 8. Now there's also this extra little number down here, and you've seen this in your gizmos before. If there's a number on the bottom, then it represents the atomic number. That it cannot change. So if it's lithium, that has to be 3. If it's carbon, it has to be 6. What I can do, though, is I could change the mass, and there's another isotope of lithium. It's still lithium, it's still the same element, which means it has the same atomic number, but notice that I changed the mass, and it's now 7. I could do the same thing. I could make that have a mass of 9 and still be lithium, and the atomic number is 3. So it's still the same atom, but it's possible for it to gain and lose weight. And so one of the things you're going to want to remember today is how to calculate the mass and calculate the neutrons. Those are the pieces that change. So you've got two options you can remember. You've seen both of these before. Mass equals protons plus neutrons, or you could rearrange it if it's easier for your brain, that neutrons equals mass minus protons. Hopefully that's in your head, but jot it in that box so you have it as a review. So here's the trick. The mass number, remember, it has to be a whole number. You don't want to have any decimals, but it might not always match what's on the periodic table. It's possible for the weight of that atom to change and be different than what the periodic table says. So here's how that looks. We're going to look at some isotopes of carbon. And so notice in the first example it just says carbon, and that means that I have no idea what the mass is. If you don't know, then you have to go to the periodic table. Okay, so find my periodic table. Here's carbon right here. And we can find all the information that we need. The atomic number is this one. Okay, so I know the atomic number is 6, and remember that protons and electrons always equal that atomic number. Since I don't have a mass anywhere in this symbol, then I'm going to have to get it from the periodic table. So I'm going to have to look here. There's the mass number. Make it a whole number. So it's 12. That's what I'll use to calculate the neutrons. So mass minus the protons equals the neutrons. There are 6 of them. So that's like a regular atom of carbon. But now maybe that carbon eats a whole bunch of cake. Well, really, that carbon is going to add a whole bunch of neutrons. Okay? So because it's carbon, the atomic number has to stay the same, which means the protons and the electrons stay the same. But now notice that this symbol added the 14 right there. If they give you that, that is the mass number. So that's what you have to use to calculate that there are 8 neutrons in this one. So I have to use that 14 because it was given. If they didn't tell me that 14, then it would look like this first example. But because they gave me that notation, I have to use the mass that was given. Now another option is in the next example, I don't know the mass, but notice what they did give me. They gave me a bunch of neutrons. So that neutron number is not the same as the original neutron number that I gave, and that's okay. We're going to use that to calculate the mass. So it's still carbon, which means atomic number, protons and electrons are still 6, but mass equals protons plus neutrons. So that means there's 6 plus 7 from here. The mass number of this thing is 13. So if I put that into the notation in that little blank, it would look like that. So those are your 3 options. If you don't know the mass, go to the periodic table. If they give you the mass, use that one. If they give you the neutrons, use that to calculate the mass. That's the goal of these isotopes. So now I'm going to walk through all of these examples on the bottom of the page. You can do any of them that you want with me, or you can just try it on your own and check in on the answers. That's very much up to you. Alright, in the first example, I know that I have lithium, and so here's lithium right here. First thing I see is the atomic number is 3, and remember that always has to equal the protons and electrons. Then I look at the symbol, they gave me 6. That 6 represents the mass number. So I'm going to use that to calculate the neutrons. 6 minus 3 equals, there are 3 neutrons in there. Okay, if I look at the next example, so I see that I have calcium here, and so I'm going to find calcium right here. The atomic number of calcium is 20, which means that I have 20 protons and 20 electrons. But now I have this 42. That's the mass number that I have to use. So I'm going to calculate the neutrons with that. 42 minus 20. This thing has 22 neutrons. So now notice the next example is also calcium, which means it has to have the same atomic number, the same protons, the same electrons. But here I don't know the mass number, but they gave me the number of neutrons. So to go backwards, you're going to add protons plus neutrons. So 23 plus 20, this has a mass number of 43. So that is what I will put into the symbol over here in the blank that they left me for the mass. Alright, in the next example, I just see some numbers over here. So I've got the proton number. Remember, protons always equals the atomic number and the number of electrons. That's going to help me figure out what element I have. So I'm going to look for element number 47 right here. That is Ag. So you could write silver or you could write Ag, either way would be okay. But now we still don't know the mass number, but they gave me some neutrons. So we're going to use that, and we're going to add protons plus neutrons equals a mass number of 108. So I'll say that this is silver 108. Alright, in the next example, I don't know what element I have, but they gave me the atomic number. So atomic number of 82 is the same as the protons and the electrons, and that's how I'm going to figure out what the element is. So I look for element number 82, it's right here. Okay, so I know that I have Pb, I have lead. And notice in the symbol that they also gave us the mass number, that's what 207 is. So I can use that to calculate neutrons. 207 minus 82 is 125. Alright, let's keep going. Next example, I have bromine. So that means I can go to the periodic table and look up bromine. Okay, here's what I know. I know that it has an atomic number of 35, so there's the protons and there's the electrons. Now I could look up the mass on the periodic table, but they gave me the mass right here. That means I have to use that one. So if the mass number is 80, because they gave it to me, that's what you'll use to calculate the number of neutrons by subtracting. So 5, carry the 1, 45 neutrons in that example. Alright, next one. I have Ta, so I can find that element, which is right here. Okay, so I see the atomic number is 73. That's the number of protons and electrons as well. Now they gave me a mass in the symbol, which means I have to use the mass that they gave. So if the mass number is 180, that's what I have to use to calculate my neutrons. So that's 7. I'll check on my calculator. Okay, and I get 107 there. Alright, a couple more examples. Let's try the next one. So here I have Ra. I know what element I have, but the blank after it means I don't know what the mass is, so we're going to be figuring that out. they give me the mass number in the chart, so I'm going to transfer that over to the symbol. Then I can go to the periodic table, look for Ra, it's right here. So that means it has 88 as the atomic number, and the protons, and the electrons. So then I can use that to calculate the neutrons. Mass number, 227, minus 88. If I subtract, I get 139. Couple more. Next one, I don't know what element I'm dealing with. They gave me the number of protons though. And remember, protons always equals electrons, and it equals the atomic number. So that means that I can go and look for the element with an atomic number of 92, hiding way down here, uranium. So it's up to you if you want to write the symbol or if you want to write the whole name of the word. Either one is okay. Then I look at the symbol and see this 235, that's the mass number. So now I can use that to calculate the neutrons. So I do 235 minus 92 equals 143. Okay, next one. Here I don't know anything about the symbol, so I'm going to have to figure all of that out. The 21 that they gave me is the mass number, so that'll go up here. And then I have to figure out what element I have, and notice they gave me the proton number, which also equals the number of electrons in the atomic number. So then I can go to the periodic table. Okay, they must be talking about neon. Again, word or symbol, it's up to you. And then we just have to figure out the number of neutrons. So mass minus protons, this thing has 11 neutrons. Okay, next element we have americium, named for your country. This is America. Alright, let's figure out what we have. Americium is way down here. Okay, the 95 is the atomic number, which equals the protons and the electrons. Now in this example, the symbol doesn't say anything about the mass, and they didn't give me the number of neutrons. So if I don't have a choice, I'm going to go to the periodic table and see down here it says the mass is 243. Since they didn't tell me, I'm going to use that as my mass number. Okay? If you don't have a choice, you have to look it up on the periodic table. Now we can use that to figure out that mystery number of neutrons by subtracting. So 243 minus 95 equals what? 148? Yep. Alright, now in the next example, it's still americium. That Am is the symbol for it. So I know that it has to have the same atomic number, same number of protons, same number of electrons. But here they gave me the mass of 244, so that's an isotope of americium. Because they gave me the mass, that's the one that I have to use to calculate, and this one is a little bit fatter with 149 neutrons. Alright, last one. Here they gave me chlorine, so if I look for chlorine, I see it's over here in group 17. The atomic number is 17, 17 protons, 17 electrons, but they gave me the mass number here. That's what I'm going to put in that missing spot in the symbol, and that's what I'm going to use to calculate the neutrons, and it has 20. Alright, that's it. Let me know if you have any questions.